Hey everyone, it's me, Miss B, and in today's video, we're looking at converting things into slope-intercept form. So this is a homework assignment for my class, and the first part of this, we're actually just working on identifying things in slope-intercept form, so that's going to be the first couple of questions here. As you may be familiar with, and even if you're not, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. It's the y value of the y-intercept. That is a strange looking p. Hang on. It's going to bother me if I don't fix it. There we go. So your y-intercept would be like a 0, comma b, and we're just going to use that value as our y-intercept. So if we take a look at this first one here, question number 1, our slope is 1 over 4, and the y-intercept is 0, comma, negative 1. So now we're going to graph, because we are supposed to identify the slope, then the intercept, and then graph it. So we're going to start at 0, comma, negative 1, negative 1, and then our slope is 1 over 4, so that means we go up 1 and then over 4. So up 1 and then over 1, 2, 3, 4. I'm going to put another dot there, and that is our slope. It does also mean that you can go down and left 4. So 1, 2, 3, 4. That'll take you into the same position. And so I'm going to start my line about here. Try to make sure it goes through all of them. There we go. And that is our graph. So that is question number 1. I'm going to try to alternate colors just so they don't really run into each other. For number 2 here, there's not really a number that we can see in front of the x to be our slope. And if you can't see a number there, it is a 1. It's just invisible. So in this case, our slope is negative 1. And you can assign that negative to either the numerator or the denominator. I like to give it to the numerator because then that determines whether I just go up or down. So I'm going to say this is negative 1 over 1. I always like to write it as a fraction if I'm then going to graph it. And the y-intercept here is positive 2, so 0, comma, positive 2. So we're going to start at positive 2, go down 1, and then over 1. And if we repeat that pattern, we will have a line that looks like this. Down 1 over 1, and if we go up 1, we go left 1. So we're gonna go right through here, and there is our line. So this is basically how we're gonna do questions 1 through 6 here. So bear with me, some of them get a little funky, but trust me, you'll be all right as we go. So let's look here and say that our slope is going to be invisible again, but it's an invisible 1. That's a positive 1, so 1 over 1, and our y-intercept is also a positive 1. So y-intercept at positive 1, and then we have a slope of positive 1, so we go up 1 and to the right 1, and if we keep following that pattern, we'll get lines that look like this. It can also follow that pattern down and to the left. Now, if you don't have a ruler, you should always try to mark all of the points. That way we can actually see what points you're intending for that line to cross through. But if you do have a ruler, or even just a straight edge, it doesn't have to be something that has markings on it. As long as it is a straight edge you can use to draw a straight line, then you're good. So this is question 3. That's going to bring us down to question 4. The slope here is the 4 over 3 that's in front of x, so 4 over 3. And then we have a y-intercept of -4, so 0, comma, -4. That means we start down at -4, and since our slope is positive, we are going up 4. So up 1, 2, 3, 4, and then over to the right, 1, 2, 3. We can follow that same pattern again, up 4 and to the right 3, and it'll place us right there. And I'm going to draw my line here. Oops, that's a little bit off center, but I'm going to move it so it lines up. There we go. Okay. And that's number 4. So on to number 5. If we have here a -3, you have to include the negative with it. It can be a little hard to see. I know that I get the benefit of zooming in on my digital copy, and sometimes those negative signs can kind of blend in with the equal sign that's in front of it, and we kind of just zoom in our brains on this, but you do have to include the negative with it. So it is -3. So that means it is -3 over 1. Since we can't see a denominator of that fraction, it's just going to be 1. And our y-intercept is also -3, so 0, comma, -3. So let's graph. The y-intercept is where you start, so -3. And then we're going to go down 3 and to the right 1, so down 1, 2, 3, and to the right 1 spot, right there. Now I can't go further down and to the right, but I can follow this pattern also up and to the left. So I am going to do that as long as you're going the opposite in both directions. You'll be part of the same line. This one's also slightly off from where I intended it to be, but I will scoot it over. There we go, just like that. And we'll put little arrows on the end here. And that's number 5. So for this last one, we have x is equal to 4. Now, I don't see a coefficient on that x, and I also don't think that this is in slope-intercept form, because slope-intercept form would be y equals mx plus b. So let's just try to graph something where x is equal to 4. So let me just plot 4 for x. That's going to be, I'll use my pink highlighter here. So if x is going to be 4, I'm going to highlight 4 here on the x-axis. And this vertical line is actually where all of the x values are going to be 4. So if I looked at them individually, we would have 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, etc. So I'm going to use that to graph my line. That's really what my line is going to look like, because y is not involved in this. It's not actually in our slope-intercept form. So our slope here is actually undefined because there is no y, so our slope is undefined. And the y-intercept, there is none. Because this one here doesn't involve y, it is just going to be a vertical line right here, and I'll put arrows on it on the ends. So that one is the one that kind of stands out here, because there's no y, so we can't have it really in slope-intercept form, and it looks very funky just because it is undefined. So now, for questions 7, 8, and 9, we are going to put these into slope-intercept form. So slope-intercept form means that we are going to basically solve for y. So one of the things that we've been doing is, on a couple previous lessons, we learned about solving for a specific variable. So when we solve for a variable, that means get that variable by itself. That's what we're going to do here with y. So I'm going to show some of the work down below. I'm going to show my work to put it in slope-intercept form down below each of these graphs. And from there, I will read my slope and intercept. So I'll start here with this one. In a thin pen, 4y plus 3x equals 16. So when I am solving for a specific variable, I like to kind of highlight that variable and then try to deal with everything else. And in this case, I'm going to move everything else away. We want to move away our separate terms first. So we'll subtract 3x from both sides. So you'll have 4y equals negative 3x. You always want to put our variable terms first, because if you remember, slope-intercept form is y equals mx plus b. Your slope is always what's attached to the x, so we want to put our x term first. And so this is plus 16, because 16 is positive. Now, there is still a 4 attached to the y, so we're going to divide everything here by 4. And this would give us y equals negative 3 over 4x plus 4, because 16 divided by 4 is 4. So this here is my answer, and from there I will get my slope of negative 3 over 4, and then the y-intercept of 0, 4. And now we're going to graph just like above. So positive 4, and then our slope is down 3, because negative 3, and over 4. And I can't really fit another pair of points on here for those, so I'm just going to estimate it here, and we will call that the graph of our line. Let's do the same thing for number 8 here. We want to, y is right here, so we want to move away our x term, which is the negative 5x, and I'm going to start by adding that to the other side. Since I didn't have a ton of room for this other one, I might start my first step up here and just kind of show that I'm going to be adding 5x. Well, I don't want to write on top of where my slope goes. Well, if I add 5x to both sides, we would end up with 4y equals 5x minus 20. And then we're left with one step of dividing everything here by 4. So we end up with y equals, this is 5 over 4x, and then 20 divided by 4, sorry, negative 20 divided by 4, because there's a minus, we need to make sure we keep that, is going to be 5, so negative 5. So we're going to start down at negative 5, because that's our y-intercept, so 0, negative 5, and then our slope was positive 5 over a positive 4, so starting at negative 5, going up 5, and then over 1, 2, 3, 4, those 2 points right there. We're going to draw a nice line right through those, and that is our line. Now number 9 here, the other two were kind of in standard form. The x and y were both on the left-hand side, and they were a little out of order. The first one had the y term first. But this one, this is not standard form. We can still take some steps to put this in slope-intercept form anyways. I am going to use the same steps where I'm going to actually take, well, let's identify where y is first. I'm getting ahead of myself. Y is right here, so I'm going to need to deal with moving this term, the plus x, and then dealing with this divided by 2 piece. So let's start by subtracting x from both sides. So I'll try to fit it in here. Y over 2 plus x equals negative 1. We'll do minus x, y over 2 equals negative x minus 1. Now we're going to need to multiply everything here by 2, or multiply both sides by 2. So we're not squaring it. I know I'm kind of writing the 2's a little bit smaller, but we're multiplying both sides. When we multiply the left-hand side by 2, what happens is the denominator cancels and we're just left with y. So I'm going to show this up here, y. And then on the right side, this becomes negative 2x, and this becomes negative 2. I want to make that color match, negative 2x minus 2. Okay, so now our slope from that is negative 2 over 1, and the y-intercept is 0, negative 2. So let's start at negative 2, and then we're going to go down 2 over 1. We can continue that pattern going down 2 over 1. Ran out of room here, we can continue to go up 2 and to the left 1 to continue our pattern, so it should be going in the same general direction, just kind of reverse. And since it's a little bit off, I am going to scoot it over just a tad so it all lines up. There we go. And so that is how we would solve questions 7, 8, and 9. And I guess I should put boxes around my answers here so that we can see what I had as my actual responses. Okay, that's going to take us to the next side of the page. For these ones, we are going to identify the slope and the y-intercept, and then write them in slope-intercept form. And so that is the rest of the assignment, is just 10 through 15. So these 6 questions, we're going to be doing the same process. So identifying our slope from a graph, I like to, just using the 2 points that are involved here, we can go down 1 and down 2. So I'm going to write a negative 2 there because we're going down. And then over 1, over 2, I'm going to write a plus 2 here because it's going to the right. Now that slope, we do the y over the x, or the rise over the run, is going to be negative 2 over a positive 2. That's going to reduce to just negative 1. And the y-intercept is going to be wherever it crosses the y-axis, and that's that big red dot right there. So that looks to me like it is at negative 3 from my origin. So 0, negative 3. So now we're going to use y equals mx plus b. And fill in that info. So y equals, now m, that's the slope, and b, that's the y-intercept. So this is going to be negative 1x, or just negative x, because you can make the 1 invisible, and then minus 3. So I'll put or underneath it, because you can also put y equals negative x. I didn't leave enough room. Negative x minus 3. Okay, so we're going to continue that process for numbers basically 11 through 15. So here, starting out, always going from the point on the left to the point on the right, I'm going to go up 1 and then over 1, 2, so plus 1 and plus 2. That means my slope is going to be positive 1 over positive 2, and it's not going to reduce. And now the y-intercept is this point right here, right in the middle, and that is at 0, 0. That means b is the y value right here. So b is going to be 0. So if I wrote this out, I would have y equals 1/2 x plus 0. Now I don't need to write plus 0 on the end, so this is also just y equals 1/2 x. So both of those would be correct if you wanted to show those. apologize for that. That is my alarm going off. I am up earlier than I normally would be. All right, so here for number 12, we're going to start from the one on the left, continue to the one on the right. I'm going to travel downwards first, so down 1, 2, 3, 4, 5, and then we need to go to the right. 1, 2, 3, 4. So I went down 5 and to the right 4. The y-intercept is this point right here. And that looks like it is down 1 space from the origin, so that is 0, -1. So my equation would be y equals -5 over 4 x minus 1. And there's not really an alternate way to write that one, just like there was for the first two, but not for that one. You have to write basically that way. Okay, only 3 more. Let's look at number 13. So starting from the one on left and going to the one on the right. I don't have to move up or down at all, so that's a +0. And then to the right, 1, so +1. So this slope is 0 over 1, which is just 0. The y-intercept is right here, and that looks like it is at 0, -1. So if I don't move up and down at all for my slope, then there's no slope. It's a nice flat line, and since I like to imagine slope as how steep something is, a little person walking on this isn't walking uphill, isn't walking downhill, just nice flat ground. So our equation, we're going to plug all of these things in the right places, and then you'll see what will disappear. So we'll have y equals, our slope is 0x, and then -1. Now what happens when you multiply anything by 0 is that it disappears, or becomes 0. So this is really the same thing as writing y equals -1. You don't need to include the 0 in front of the x, because you don't need to include the x term at all. So y equals -1. All right, now this one here, they didn't give us points on. So instead of using the points that they indicated, we're going to find our own. I like to use the y-intercept if I can see it. And then I do see another point here over to the right. So it looks like we go up 1 and then to the right 2. So my slope should be 1 over 2. And then that y-intercept looks to me like it was down 2 from the origin. So 0, -2. Now our equation is then going to be y equals 1/2 x minus 2. And that's it. Number 15, we're going to do the same thing, identify some points of our own. I do see the y-intercept here, so I'm going to mark that one, but I don't see anything further to the right because it kind of goes up and off my screen. So I am going to find one here. There are some that it looks really, really close to, but the only one I can see for sure is going to be this point down here. So even though there might be some points in between, I know that my slope will always reduce if I don't see those and I have something that I can look at instead. So in this case, I'm going to start from the one on the left and then go to the one on the right. So I would have to go up 1, 2, 3, 4, 5, 6, 7, 8. That's a +8. And then 1, 2, 3, that's +3. So my slope should be 8 over 3. And my y-intercept here is this piece. This looks like it is +4, 1, 2, 3, 4 above my origin. So 0, +4. And we'll write our equation out. Y equals 8 over 3 x plus 4. And that's it. That is our whole assignment. So thank you for sticking with me through it. I know the previous assignment was very long. Hopefully this one was significantly shorter, and hopefully my explanations helped you understand it. So again, this has been converting things to slope-intercept form for Algebra 1.